Imagine paying $30,000 to have a massive drilling rig just completely tear up your beautifully landscaped backyard.
Yeah. It's intense.
Right. And knowing you will literally never see the machinery you just bought once the grass grows back. I mean, that is the raw, unglamorous reality of residential geothermal energy.
It really is. It completely shatters our, normal expectation of what a home improvement project actually looks like.
Yeah, for sure.
Because usually you buy a premium appliance, they wheel this shiny metal box into your kitchen or out onto your patio, and you can point at it.
Right. You can show your friends exactly where your money went.
Exactly.
Yeah.
But geothermal, on the other hand, is basically an invisible infrastructure project disguised as an air conditioner.
Which brings us to our mission for today. So, welcome to the deep dive, everyone. We are taking the glossy, heavily photoshopped marketing brochures off residential geothermal energy.
Stripping it all the way down.
Yep. And we are looking at the raw, real-world numbers as they stand right now in 2026.
And for this analysis, we are pulling from a really fantastic boots-on-the-ground transcript from a show called Cool Talk with Hartzells.
It's a great source.
It really is. It features hard data from an Oklahoma contractor named Dave Hartzell, and it's layered with some great insights from Climate Master Homeowner News.
So when you hear the word geothermal, your gut probably does two things simultaneously. First, you think about hot springs or like volcanoes.
Right, naturally.
And you assume it must be this incredibly eco-friendly thing. But second, you assume it sounds like a luxury that costs, I don't know, $100,000.
Which effectively locks out normal homeowners, yeah.
Exactly.
And that tension, right, between wanting this elegant green solution and then just staring down the barrel of a standard household budget, that is the central conflict for anyone looking into this tech today.
Okay, let's unpack this, because we are going to find out exactly what it costs to install a standard 3 to 5 ton system today.
Yeah, let's get into the numbers.
But actually, just to clarify for you listening, because the word ton always throws people off when we talk about air conditioning, we aren't saying contractors are dropping an 8,000-pound piece of metal into your basement.
No, definitely not. A ton in the HVAC world simply measures how much heat the system can move in an hour.
Right.
Specifically, it's 12,000 BTUs. So a 4-ton system is just moving 48,000 BTUs of heat.
Which is pretty standard, right?
Yeah, that's the standard capacity required to keep like a mid-sized single-family home perfectly comfortable.
Got it. And to be completely clear to our listener, we aren't looking at theoretical best-case scenario brochure numbers here. We are looking at real quotes based on a typical single-family home in Kingfisher County, Oklahoma.
Kingfisher County serves as the perfect test case. It really grounds our entire discussion in reality.
Oh, absolutely.
Because we aren't dealing with hypotheticals drawn up in some corporate office. We're dealing with actual dirt, brutal weather swings, and actual utility companies.
Right, the real world. So let's just look at the raw invoice before we even talk about whether this massive investment is actually worth the money.
Yeah, you need to understand what you are actually buying first.
Exactly. A turnkey residential geothermal install on a typical Kingfisher home before a single rebate is applied ranges wildly from $25,000 to $40,000.
That is a staggering number. But that turnkey number covers a massive amount of labor and equipment.
Okay, what does that actually include?
It includes the indoor unit, the expansive loop in the yard, the de-superheater for hot water, all the electrical work, the permits, and the final commissioning.
Okay, I have to pause on the word de-superheater because that sounds like a comic book weapon.
It kind of does.
But in reality, it's like one of the most brilliant parts of the system.
Oh, it's genius.
Imagine running your air conditioner all summer, and instead of just throwing all that heat from your living room out into the atmosphere, the de-superheater captures that waste heat.
And pumps it directly into your water heater.
Yeah. Yes. You essentially get free domestic hot water for months just by cooling your house.
It is a stunning piece of efficiency. You are recycling energy that would otherwise just be completely wasted.
But even with cool tech like that, I still have to push back on that initial price tag. I mean, $25,000 to $40,000 is a massive range.
It's huge.
That's a $15,000 swing. Wait, $15,000 just to bury some plastic pipes. I can buy a top-of-the-line traditional AC for half that.
Right, it sounds crazy.
What exactly is happening in that dirt that justifies the price of a compact car? Am I just paying tens of thousands of dollars for mud?
What's fascinating here is exactly what makes up that premium. The biggest cost variable, the singular thing that swings that price tag by $15,000 is the loop.
The loop.
Yeah, the loop is the heart of the system. It is the component that actually makes a geothermal system, well, geothermal.
Because I think a lot of people picture this technology as just a super fancy furnace sitting in a closet somewhere.
Right. But the furnace part is actually secondary to the physics happening out in the yard.
Okay.
The loop is a massive closed circuit of incredibly durable polyethylene pipe. It's filled with a mixture of water and a little antifreeze, and it just runs out under your lawn.
Just buried out there.
Buried out there. It continually exchanges heat with the earth and circulates back to the house. And the science of why this is necessary is brilliant.
How so?
Well, if you dig just 6 feet underground in Kingfisher, Oklahoma, the earth sits at a constant, completely stable temperature of 55 to 60 degrees year-round.
Which doesn't sound that crazy until you put it into the context of extreme weather.
Exactly.
I actually like to think of this system as a thermal cheat code. Unlike a regular AC that has to fight whatever chaotic weather is happening outside, a geothermal system is just coasting on that stable underground temperature.
Right. Think about the pure physics of August in Oklahoma.
Brutal.
It's 104 degrees outside. A traditional air conditioner has to take the heat from inside your living room and try to force it into that 104-degree air.
It's fighting an uphill battle.
A massive uphill battle. It consumes massive amounts of electricity just to make the transfer happen. But your geothermal loop,
It's dumping your house's heat into ground that is 45 degrees cooler than the outside air.
exactly.
The thermal cheat code. It is infinitely easier to push heat into a cool 55-degree space than a boiling 104-degree space.
And the mechanism works the exact same way in reverse. In January, when a brutal winter storm rolls through and it's, say, 12 degrees outside,
Right.
a traditional heat pump is desperately trying to squeeze whatever microscopic amount of heat it can out of that freezing air. But your geothermal loop is pulling heat out of ground that is 40-plus degrees warmer than the winter air.
So the loop is doing all the heavy lifting for the entire house. But let's get back to my skepticism about that $15,000 price swing. Why the massive variation just for putting these pipes in the ground?
It all comes down to the two different installation methods, which are dictated entirely by the reality of your specific property.
Okay, so what's the first option?
The first option is a horizontal loop. This involves bringing in a backhoe and trenching 5 or 6 feet down across a wide, flat backyard.
Got it.
If you have the sprawling space for it, a horizontal loop on a typical Kingfisher house runs roughly $6,000 to $10,000.
Okay, so 6 to 10 grand is a big chunk of change, but it keeps you closer to the $25,000 end of that total install range we talked about.
Right.
It feels painful, but manageable.
But what if you live on a tiny lot? Or what if your soil is full of dense, impenetrable rock? You can't just dig a shallow trench.
That makes sense. What do you do then?
You are forced to go with a vertical loop. This means bringing in an industrial drilling rig to bore holes 200 to 300 feet straight down into the earth.
Let me stop you right there, because the phrase 300 feet is hard to conceptualize.
It's deep.
For you listening, think about a standard commercial office building. 300 feet is the equivalent of taking a 30-story skyscraper and drilling it straight down into your front lawn.
It is wild.
The sheer magnitude of that operation is staggering.
It's a massive engineering undertaking. And because it requires heavy, specialized machinery, significant labor, and extra time, a vertical loop can run $12,000 to $20,000.
Wow.
And that depends entirely on how many of those deep bores your home requires.
Suddenly, the massive swing makes total sense. You start with a $30,000 horizontal job. The contractor hits a layer of solid limestone you have to swap to a vertical loop, and you are immediately pushing $38,000 or $40,000.
Yep.
You are literally paying a premium for the difficulty of your own dirt.
You are paying for the geology of your property.
Yeah.
But if we connect this to the bigger picture, there is a massive hardware advantage to this setup that offsets a significant portion of that initial financial pain.
Oh, real?
Yeah, because the subterranean loop is doing all the hard work outside, the actual indoor equipment, like the Climate Master Geolite unit mentioned in our source material.
The furnace part.
Right, it gets to live an incredibly sheltered life.
It's just sitting in a perfectly climate-controlled mechanical room in the basement or a closet.
Exactly. It is sealed indoors, operating in a comfortable 60-degree environment year-round, rather than baking in the sun during a 100-degree Oklahoma summer or taking on ice in a winter storm.
That makes a huge difference.
There is no outdoor condenser unit for the dog to pee on, no fan blades exposed to hail, no metal coils rusting in the rain.
That's a great point.
This massive reduction in thermal stress and elemental exposure means these indoor units boast a 20-plus year lifespan.
Okay, so the tech is solid, the physics make absolute sense, and the lifespan is phenomenal.
Right.
But we are still staring at a piece of paper with a number that can easily approach $40,000 for a vertical install. How does anyone actually afford this?
It's tough.
I mean, 40 grand is the price of a luxury car.
This is where the financial landscape has drastically shifted, and where you, as a homeowner exploring this option, need to be hyper-vigilant.
Here's where it gets really interesting. Because if you've looked into geothermal anytime in the last decade, contractors soften the blow of that $40,000 invoice by dangling a massive federal tax credit in front of you.
They sure did.
But here is the stark warning from Dave Hartzell. The 30% federal tax credit, known formally as Section 25D, expired on December 31st, 2025. It is entirely gone.
This point cannot be overstated. If you are sitting at your kitchen table in 2026 and a contractor is trying to sell you a geothermal system by quoting a 30% federal tax credit, Hartzell's advice is clear.
What does he say?
They are either horribly misinformed about current tax law or they are actively lying to you just to win a sale.
It is a terrifying trap. You sign a contract thinking you're getting $12,000 off a $40,000 bill, only to find out from your accountant in April that you owe the full amount.
A total nightmare.
So, with the federal government completely stepping away from residential subsidies, what is the solution? How are people making the math work without Washington footing a third of the bill?
Well, the financial focus has shifted entirely away from the federal level and down to local utility rebates.
Okay.
And what is truly fascinating here is just how hyper-local this incentive structure has become. The federal safety net vanished, so your entire financial strategy depends entirely on exactly which utility company logo is stamped on the meter spinning on the side of your house.
But why would a local utility company be willing to hand a homeowner thousands of dollars to install a fancy air conditioner? It almost sounds like a scam.
It does, but you have to look at the motivation of the utility providers. They do not care about lowering your personal monthly electric bill.
Obviously not.
They care about managing peak demand on their grid. Picture a sweltering Tuesday in August. Everyone in the state gets home from work at 5 o'clock and cranks their traditional air conditioners.
Oh, right. And the power grid suddenly screams under the massive spike in electrical load. And if the grid can't handle it, they face rolling blackouts, or they are forced to fire up peaker plants.
Which are incredibly expensive.
Yeah, they're essentially backup power stations that are just hugely inefficient to run.
Yes. So, for a utility company, handing you $4,000 to install a highly efficient geothermal system that barely sips electricity during that 5 o'clock rush, that's a bargain.
Wow. Yeah.
It saves them from having to build billion-dollar power plants to handle summer spikes.
That makes perfect sense. So let's look at the specific Oklahoma utility examples from the source material to see how local this gets.
Sure.
OG&E pays a very solid $1,000 per ton of capacity. Cimarron Electric pays a flat $600 across the board, regardless of size. OEC pays a sliding scale between $400 and $700, depending on the specific equipment you install.
Your neighbor living a mile down the road could secure a radically different rebate just because they are hooked up to a different localized grid.
And then there's Seek Energy. According to the source, Seek Energy pays a massive $2,000 per ton.
It's huge.
It's capped at a maximum payout of $24,000, but that is an enormous financial incentive. On a standard 5-ton system, that's 10 grand knocked right off the top of the invoice.
It is a game-changing amount of money. But there's a massive catch, and it perfectly highlights how careful you have to be with this hyper-local landscape.
What's the catch?
Seek Energy serves 10 counties in western Oklahoma. Kingfisher County, where our baseline home is located, is not one of them.
Oh, wow. So if a smooth-talking contractor comes to a house in Kingfisher and casually mentions that massive Seek Energy rebate to make their $40,000, quote, look palatable,
They are dangling incentives that legally do not apply to that homeowner.
that's a raw deal.
It is. It's a calculated tactic to win the sale, but ultimately lose the trust of the client. You have to independently verify exactly what your specific utility provider offers.
Okay, let's run a real-world mathematical example so you listen can actually feel how this shakes out. Let's assume you have a typical house. You get a mid to high level 4-ton system installed. You have a sprawling flat yard, so you get the cheaper horizontal loop.
Sounds good.
The initial turnkey cost on the invoice comes to $32,000.
And for this scenario, let's assume you have an OG&E meter attached to your home.
Perfect. So we take that $32,000, we subtract the OG&E geothermal rebate, which is $1,000 a ton for a 4-ton system, giving us a $4,000 discount.
Right.
Then our source notes there is an additional $1,500 rebate from OG&E if this qualifies as a total HVAC swap. So subtract another $1,500.
Which brings the true out-of-pocket net cost to the homeowner down to $26,500.
$26,500. It is certainly better than the initial $40,000, but it is still a massive investment of capital.
Absolutely.
The natural next question is the one every homeowner ultimately faces before signing a check that big. Does spending that much money actually pay for itself over time?
This raises an important question because calculating the payback period on geothermal is absolutely not a one-size-fits-all equation. The math is incredibly squishy.
Squishy is the perfect word for it. Let me pose a highly skeptical scenario on behalf of the listener. Let's say I have a perfectly fine 5-year-old high-efficiency air conditioner.
Right.
It works. The house is perfectly cool in the summer and warm in the winter. Why would I ever voluntarily tear up my beautiful landscaping and drop 26 grand on this project?
The blunt answer: you shouldn't.
Really?
Yeah, and this is exactly where honest contractors separate themselves from desperate salesmen. The payback math entirely depends on what existing infrastructure you are replacing.
So I imagine if I'm running an old rattling propane furnace from the 1990s, I'm probably the ideal candidate for this, right?
Oh, 100%.
Because I'm already bleeding money every single winter just to keep the house at 68 degrees.
You hit the nail on the head. The best candidates are homeowners replacing an archaic propane furnace paired with a tired, inefficient AC unit. Propane is notoriously expensive and subject to wild market fluctuations. If you swap that old, fuel-heavy dual system for geothermal, our source notes you might save between $1,200 and $2,000 a year on energy costs alone.
$2,000 a year in pure savings. That is real money staying in your checking account.
It is substantial. And when you factor those annual savings against the $26,000 net cost, you are looking at a simple payback period of roughly 12 to 18 years.
Wow. Okay.
After that period, every dollar saved is pure profit. It also makes incredible financial sense if you are building a brand new home.
Why is that?
Because you can roll the cost of the yard loop directly into your 30-year mortgage, making the monthly premium increase virtually unnoticeable.
Oh, that makes a ton of sense.
Or, if your existing system is completely dead, you'd be forced to spend $15,000 on a standard replacement tomorrow anyway.
The premium to step up to geothermal is much smaller in that emergency scenario. So, if you are bleeding money on propane, building from scratch, or forced to write a massive check for a dead system anyway, taking the leap makes incredible sense.
It really does.
But what about the bad candidates?
Going back to your earlier scenario, replacing a perfectly good 5-year-old high-efficiency system.
Yeah.
If you rip that out for geothermal, your energy savings are going to be drastically smaller, maybe only $600 to $1,000 a year.
Because the system you were already running was already doing a pretty decent job managing the electric bill.
Exactly. And saving only $600 a year means your payback period stretches to 25 years or more.
Ouch.
From a pure financial perspective, locking up that much capital for a quarter of a century just doesn't make sense.
The source material actually gets really specific about this. They essentially provide a do-not-buy list.
Yes, they do.
These are specific scenarios where geothermal is just a terrible idea, and an honest contractor should look at your house and tell you to walk away.
For instance, if you have a very small, rocky lot, you do not have the square footage for a cheap horizontal trench, and the dense rock makes drilling those vertical bores incredibly slow and expensive.
Right.
The loop cost will completely blow your budget out of the water before the equipment even arrives.
Or, and I found this psychological aspect really interesting, if you are planning to sell the house in the next 3 to 5 years.
Oh, yeah.
Picture a young couple touring your house. They walk into the kitchen, see the gleaming quartz countertops, and their eyes light up.
Naturally.
Then the realtor takes them to the backyard, points at a patch of perfectly normal-looking grass, and says, hey, there is $30,000 of thermal capability buried under there. The buyers are just going to blink at them.
Totally.
Yeah.
The general buyer pool values the aesthetic and the immediate. They see a thermostat on the wall, and as long as cold air comes out of the vents, they check the HVAC box in their minds. They do not fully understand the technology yet, so you are not going to get that $26,000 premium back in your asking price. Buyers see a working AC. They do not necessarily assign a premium value to the underground thermal cheat code.
And the final item on the do not buy list relates to your existing ductwork. If the ducts running through your attic are undersized, leaking air into the insulation, or just generally in bad shape.
Which is pretty common, honestly.
Right. Putting a premium geothermal unit in the basement will not magically fix your house. You have to spend thousands of dollars fixing the ductwork before the system can actually deliver on its efficiency promises.
It is a holistic ecosystem. Putting a state-of-the-art million-dollar engine into a car with 4 flat tires is not going to win you a race.
Great analogy. So what does this all mean? We've stripped away the glossy marketing. We've looked at the reality of dead federal tax credits. We've explored the bizarre world of hyperlocal utility rebates. And we've walked through the brutal reality of the payback math.
It's a lot to consider.
It is. But the core message for you listening is this. Surviving the geothermal sales pitch in 2026 requires actively ignoring brochure numbers. You need 3 real things.
Right.
You need a real mathematical load calculation of your specific home, a real loop assessment of your specific BERT, and a real check of your specific utility meter.
It is the ultimate custom installation project.
Mhm.
It demands surgical precision up front so you aren't financially surprised on the back end.
But before we wrap up this deep dive, I want to leave you with one final lingering concept to chew on.
Okay.
We talked earlier about how the indoor unit, because it's sheltered from the weather, lasts for 20 plus years.
Yeah.
But we barely touched on the lifespan of the loop itself.
The polyethylene pipe buried deep in the dirt.
Exactly. Once that loop is in the ground, it essentially lasts forever. It doesn't rust, it doesn't degrade, it just sits there exchanging heat with the earth decade after decade.
It's incredibly durable.
So given that the loop is a permanent fixture, should we stop thinking of geothermal as an appliance upgrade altogether?
That is a fascinating perspective. It challenges the entire financial model of how we view home improvements.
Maybe we need to stop comparing it to buying a stainless steel refrigerator and start treating the subterranean loop like a permanent piece of home infrastructure.
Oh, I like that.
You don't calculate the payback period on your home's concrete foundation. You don't ask what the return on investment is for your indoor copper plumbing.
Right, because they are fundamental, permanent parts of the property that make the house livable.
Exactly. If the loop outlasts you, your kids, and the next 3 generations of indoor heat pumps, is it time we fundamentally change how we value it?
It completely reframes the initial sticker shock when you realize you are buying a permanent generational upgrade to the earth beneath your home.
It changes the whole conversation. Well, thank you for joining us as we unpacked the real, unvarnished numbers behind geothermal energy in 2026.
It's been great.
You are walking away with an expert-level understanding of what it really takes to harness the temperature of the earth. Keep questioning the brochure numbers, and we'll see you on the next deep dive.